Okay, here are the beginning of your gas law notes. We have to start with pressure and converting pressure. Let's see. Okay, here is the first set of notes that you will need. Pressure is defined as the force per unit area on a surface. It's just a definition. You will also write that in your vocab, so you can write it or not, up to you. You do need these bullets, though. The gas pressure is caused by collisions. If you have less volume, those collisions are more frequent. If you turn up the temperature, they move faster and the collisions are more frequent. But either way, pressure is caused by those gas particles running into each other, okay? The pressure is going to depend on volume, temperature, and number of molecules present, okay? This is a good note to have down here. The greater number of collisions, the higher the pressure will be. Temperature makes those collisions go up, higher temperature does, and less volume, so when you squeeze it in a small space, the number of collisions also goes up. Okay, so our flash player isn't working anymore. Okay. Okay, pressure is the force per unit area. So the pressure of a 500 Newton person on a area of floor is 3.25 centimeters cubed, okay? The greater the force in a given area, the greater the pressure, okay? Let me just, since that flash player isn't working, I will give you the, I will write the equation on my paint slide in just a minute, since that flash player wasn't working, for the equation for pressure, okay? But it has everything to do with force over area, okay? F over A. Forces in newtons, areas in centimeters cubed. So the pressure, that's one way to represent pressure there. All right, all good stuff. I would write that down in your notes. This is a good visual for that. You see she has, the area is large, so her pressure is smaller. When she gets on her toes, the area gets smaller, so the pressure gets larger. She's got more pressure here, okay? Her force is the same every time. It's just what she weighs. That's not changing. See, it's 500 the whole time. Then when she gets up on one toe, the pressure is the most because it is all concentrated in the smallest area right here. And I said I was going to write the equation, but here it is right here. It's a little small. Pressure equals force over area. So you can write that equation down from right here. Pressure equals force over area. Okay. You absolutely need this information. It's very important. It's basically talking about where these barometers came from. Who came about making a barometer, and it was Torricelli. That was the guy's name, okay? He reasoned that if the maximum height of a water column, okay, there's water in it, depending on its weight, then mercury, okay, is 14 times as dense as water. You could only raise it up a 14th as high as water because it's 14 times more dense, so it wouldn't go up as high as water, okay? He tested this idea by, well, and listen, the reason why he's doing this is because it's not feasible to use water as a measuring device because it goes up too high, okay? Mercury is more dense, so it wouldn't go up as high, so you could make a small version of it, okay? He tested this idea by sealing a long glass tube at one end, filling it with mercury, and inverting it into a dish of mercury. When he did that, the mercury rose to a height of 760 millimeters. Now you're going to see this used all the time. That's going to be the standard unit, one of the standard units of pressure, 760 millimeters. But I want you to be able to basically explain this, how that came about and how he discovered that, okay? Let me see if this is a flash player, if we can watch this. Nope, okay. Definition though, device used to measure atmospheric pressure and air pressure you would need. Okay, so the common unit for measuring pressure is millimeters of mercury. You will see it all the time. So this is a unit, mmHg right here, okay? Also, it's called millimeters of mercury. It's also called torr in honor of Torricelli because he invented the barometer. So sometimes it's called torr, T-O-R-R. Okay. Pressures can also be unit in atmospheres. So we have different units for pressure. I'm going to show them to you in just a second.
Keelan Tidwell, please come to the office.
Okay, here are our different units. We have Pascal, millimeters of mercury, atmosphere, and torr. These are the abbreviations. It would be good to note that we also have kilopascal, kPa. This is an example right here. I'm going to show you in just a minute. But these are our standard units of pressure right here. Here are their symbols. Okay, you have to be able to convert between them. Okay, for the sample problem, we're going to just go do some over here. Okay, so what I've done here, and you're going to want to write this down, is I have listed your standard pressures for you. 1 ATM, 760 mmHg, 760 torr, because they're really the same thing. This one's just named after Torricelli. 101,325, that is a comma, PA, pascals, and then 101.325 kPa, which are kilopascals. All right, I'm going to do a couple of short conversions for you. They're not hard. If you need to convert between ATM and mmHg, you would set it up in your dimensional analysis box, 760 ATM. Hope I don't get too sloppy here, but ATM on the bottom, like always, and then I can go to mmHg on top. Now, my units, my conversion units here are these common ones. So for ATM, I'd put 1, because that's what it is here. And for mmHg, I'd put 760. Okay. Then just stick that in your calculator, which is what I'm doing now. 0.760 times 760. The answer is 5. How many sig figs? 3 sig figs? 578 mmHg. Nothing to it, okay? These are pretty basic. For this one, we'd take our given. That's not a decimal, sorry. Made a stray mark there. There, kind of got rid of it. 760 torr. Put torr on the bottom. Cross it out and go to kPa. For torr, 760 is my number. And for kPa, 101.325 is my number, equals. So 671 times 101.325. The top number is really big. 6798 divided by, and then 760 on bottom. It's going to be, we need 3 sig figs, 89.5 kPa. Okay, last one. That's not a decimal. 177 kPa. kPa. Cross out. Go into ATM this time. 1. And then kPa is right here. So didn't leave myself enough room, but I'll try. 325. All right. So it's going to be 177 over 325. Three sig figs would be 1.75 ATM. Okay, so for now, you just need to know, remember how to convert these. You need to be able to convert between pressures and basically explain the history of pressure and where it came from. Okay, and that's it for these notes.